In this video, we will be continuing with learning how to simplify radicals with negative radicands, but specifically if they're roots or indices, or an even index, I should say. An even index or an even root, and if that number under the radical is negative. So things I need you to remember. The very first day of class, we talked about the complex number system, and you had a graphic organizer, okay? And in that complex number system, we said that numbers can either be real or they could be imaginary. So now's when that's coming back. So imaginary numbers exist when we take the square root of a negative number. And I'll use n for number. In fact, the imaginary number is actually, we usually italicize it also, so it doesn't look, it couldn't get confused as a 1. So make sure you kind of put a little tail on the end, okay? So the imaginary number I is what we're referring to. Now what this means is whenever we see the square root of a negative number, say the square root of -5, the first thing I want you to do is go, oh, this means I need to put an I out front and make it positive. And why? Because the imaginary number I is equal to the square root of a -1. So that means when I have the square root of -5, that's actually the square root of -1 times the square root of 5. The square root of -1 being I, and then the square root of 5 being an irrational number that we can no longer simplify. So therefore, our answer would look like I square root of 5. So let me kind of recap. The complex number system is made up of real numbers and imaginary numbers. We've already talked about real numbers. These are your rational and irrational numbers, which we've just tested on. The imaginary numbers come from taking the square roots of negative numbers. So if I take the square root of a number and it has a negative number under the radical, all I'm going to do is put an I out front and make it positive. And then if I can simplify what's inside, I would. And the reason is that the I is equal to the square root of -1. So again, for example, if I have the square root of -5, that's equal to, if I break this down like I did before, the square root of -1 times the square root of 5, where the square root of -1 is simply I. So I'm not saying you're going to have to show all this work. What I'm saying is all I need you to do is put an I out front and make the radicand positive. Now this is going to happen whenever I take an even root of a negative number. So it doesn't just apply to square roots. So if I take the square root of a -5 or the fourth root of a -5 or sixth root of a -5, etc., I would end up with, in this case, I root 5. In this case, I fourth root of 5. And in this case, I sixth root of 5. Okay? So this is only going to happen when that index is even. And remember that we have an understood 2 here, which makes that index even. All right? The only difference is, look, I keep my root, square root, fourth root, sixth root. So this is going to be a really easy section and a short video. All we have to do is go through 5 problems, and we've already talked about how to use our calculator, and so that's what I'm going to continue to do. So I'm going to do in this video 11 through 15, and then I'll be done, and then you'll go type in the answers for 11 through 15, and then complete 16 through 20 independently. So I'm just going to, if you don't mind, copy down all these problems. So 11 is the square root of -27. So feel free to write these down. I'm going to leave a little room because I am going to at least expect you to write down what you typed in your calculator, or if your preference is to do it by hand, what you got when you typed it in that way. So 12 in my notebook, I'm going to write square root of -28. Leave some room. 13, 14 and 15. So for 13, did I write that in the wrong spot? Did I not click on 12? My apologies. That was the square root of negative 150 for number 12. And then 13 was the square root of negative 28. Sorry. 14 is the square root of negative 12. And then negative 147. All right. So I'm just going to go ahead and we're going to find all the answers for these, and then I'm going to show you how to type in a couple of them in Delta Map. So for number 11, so first things first, whenever we see square root of a negative, again, the first thing we do is put an I out front and make them positive. So notice I'm just putting an italicized I out front and changing my negative to a positive. You'll do that every time we take the square root of a negative. And that I, by the way, will always go directly in front of the radical. Okay? Now, all I got to do is simplify square root of 27, which I'm going to do quickly in my calculator app. So if I go to y equals and I type in 27 divided by x squared, I explained how to do that in the last video. And our job is to look for what? The last integer ordered pair. Let it focus. Now I'm going to press second and then the graph button to go to my table. And I like to start back up here at 0. And my job is to look for the last whole number ordered pair. So I've got 1 and 27. That's a whole number ordered pair. But it's not the last one because I've got 3 and 3. Are there any more? Nope. My last one is 3 and 3. So what I want to see you do is come over here and put an XY table. Oops, sorry. An XY table with 3 and 3. And that makes our answer 3i root 3, or 3i square roots of 3. So again, this I, we cannot forget to keep it in our answer, but where did I say it goes? Directly in front of the radical. So while your calculator is going to give you 3 and 3, you have to remember to insert the I directly in front of the radical. You cannot, by the way, go to y equals and type in negative 27 divided by x squared and get an I answer. Okay? It's going to give you 3, negative 3, and that would be wrong because if you put the negative 3 under the radical, it means you need the I out front. Okay? So again, just remember to keep your I right there. So some of you may have looked at this and said, I can do that in my head because what does that give me? Square root of 9 times the square root of 3, and then the square root of 9 is 3. So that's how I do it. I put my 3 out front and go, oh, it's 3i square roots of 3. So those of you good with perfect squares may prefer to do that. And that's fine if your work shows that as well. So 150 divided by x squared in my calculator. Trying to make it so you can see it. Second graph, looking for my last integer ordered pair. I've got 1 and 150, 5 and 6. Oh, and now I'm in my 0 point whatever. If I get to 0 point something, I'm done. So 5 and 6 is the most I can, is the lowest one I'm going to find. So I'm going to come over here and do a table x, y, and that was 5 and 6. And bringing those down means I have 5i square root of 6. If you do not type it in with the I in Delta Math, it will not be correct. All right. So next for 28, again, some of you may look at that and think of your perfect square factor right away. So again, I'm typing the positive 28 divided by x squared, looking for my last integer ordered pair. And I see 1 and 28, 2 and 7, and that's it. So it's 2 and 7. Okay? Can y'all see that? Or y'all should be doing this in your calculator with me. 2 and 7 is my last one. So on my table, I'm going to say, and this is what we should see for this work, guys. 2 and 7, bring it down, 2i square root 7. Hopefully you're finding this is pretty easy. Now, some of you may, again, I've looked at that and said, oh, if I did that in my head, what would that be? Well, that's the square root of 4 and the square root of 7, where if I bring my 4 in the front, it's 2i square root 7. Just a thought. Some of you may prefer that. In fact, you might look at this and go, I can do that in my head, because that's the square root of 4 and the square root of 3. The square root of 4 is a perfect square. I'll put its value out front and get 2i square root 3. But again, one of these methods is necessary. You either have to show me what you're using to reduce and get that answer, or you have to do the xy table, either one. So 12 divided by x squared. I'm going to hit second graph to look at my table, look for my last integer ordered pair. And my last integer ordered pair, now I'm in the zeros, so my last one is 2 and 3. So, again, xy table, 2 and 3. Just make sure you put the I in front of the radical. So got to see that. That's like your work. That's your work right there. All right. And for number 15, if I've got 147, I can't think of any perfect square factors offhand. So I'm going to go to y equals, type in 147. So again, I'm typing in 147 divided by my x is here beside the green alpha key and my squared down here, x squared. Then I press the blue second button, then the graph key to go to my table. Let me zoom a little better. I see 1 and 147. And I see 7 and 3. Yep. So 7 and 3 are my last integer order pair. So x, y, 7, 3, 7 on the outside, 3 on the inside, but I can't forget my I. All right. And that's it. And then you're going to go ahead and type in the rest of the values. The only other thing I want to do real quick is show you how we type this answer in. So I'm going to go back to 11. And from your notebook, our answer for number 11 was 3i root 3. So I'm going to type 3. Then I'm just going to type the letter I right on my keyboard. Okay, above the letter K, there's an I. So I, then root, for square root, and then 3, the radicand. Hit submit answer, and that's it, guys. So go ahead and finish typing the remainder of these answers in for through 15, and then do 16 through 20 on your own in your notebook. Make sure you are showing your work, then take a picture of everything and submit it in Canvas. Thanks, guys. Let us know if you need help.